Hello people, I'm Acharya. Welcome to a new video. So in today's video, we're going to learn ICWs and OCWs. What are they? Initialization command words and operational command words. Yeah, that's their full form. What do they mean? They are commands given by the programmer to 8259 to initialize 8259, to make it work according to his or her requirement. When you use 8259, everybody may not want to use 8259 in exactly the same way. All chips that you learn, peripheral chips, 8259, 8255, 8237 and so on, they are all programmable chips. That means the programmer decides how the chip should work, and that's a good thing. If the chips would by themselves decide how they want to work, then why do we need programmers? Why do we need engineers? Our job is to set up the chip as per our requirement. So that's what we do in this by these commands. So that's what we're going to be learning in this lecture. Now, I've already done the video on ICWs and OCWs, but that was for 8086. These are commands given to 8259 if you're programming with 8085. 70% is the same, but there are changes. There are significant changes. Okay, so if you're learning 8085 and you're learning 8259 with respect to 8085, this is the video you need to watch. Now, you have the background of 8259. It is used to increase the number of interrupts. The first thing that you need to do is initialize 8259. For that, you need to give these commands. These commands are given by the programmer to 8259 through the data bus of 8259. Now, that data bus is 8 bits. That is why all of these commands are 8-bit commands. Now, let's give you a brief idea what these commands are before we start learning them. These commands are divided into two categories. They are called ICWs and OCWs. Initialization command words and operational command words. As the name suggests, what will we give first? ICWs. That's how you initialize 8259. You know, initialization of 8259 is compulsory. That means doing this is compulsory. This is where 8259 will become ready once you have given all the commands. Are you clear? Now, OCWs are optional. You may give them, you may not give them. That's okay. But ICWs are compulsory. Not only compulsory, they have to be given in this sequence only. Now listen to all of these words that I'm saying. Right at the end of this video, all of this will come back together in a mind-blowing way. At that time, you'll be amazed how crazy this is and how much thought process is gone. Just 4 days back, I was teaching this topic in the class to one student, to the students, and one student asked, it's unbelievable how they could think of so much at that time. This is 40 years back. Anyway. So, what did I say right now? ICWs have to be given in this sequence only, and there's a very good reason for it which will come later. So, first you give ICW1, then 2, then 3, then 4. No other order will work. OCWs can be given in any order because they are not compulsory, so they don't depend on each other. You can give them in any order, any sequence that you want. Moreover, ICWs cannot be repeated. If you want to understand programming of 8259, which we'll do in this video, after the theory, we'll be doing programming of it. If you want to understand that programming, remember these rules. ICWs cannot be repeated. That means you give ICW 1, then 2, then 3. Now you are supposed to give ICW 4, but you realize, oh, I've made a mistake in ICW 3. I want to give it again. Sorry, too bad, not possible. You cannot repeat any ICW individually. If you want to give them again, give the whole sequence again. That is allowed. Giving the whole batch of ICWs as many times as you want to is allowed, but individually no ICW can be repeated. Have I made myself clear? No such rules on OCWs. They can be given in any order. They may not be given at all. They can be repeated as many times. So OCWs are totally flexible. ICWs have the rules. So let's just go through the rules once again. Who are given first? ICWs. Who are given in a sequence? ICWs. Who are compulsory? ICWs. Who cannot be repeated? ICWs. OCWs, no rules apply. Now, ICW1 and ICW2 are absolutely compulsory. No matter what system of 8259 you're making, whether you're making a simple system or a complicated system, doesn't matter. ICW1 and 2 have to be given. ICW3 is given only if it is cascaded. You know what is cascaded 8259? So if it's a cascaded system only, then you give ICW3. If it is single, you skip it. Same goes with ICW4. It is given only if needed, required. We will be learning. When I teach you ICW4, you'll automatically understand when is it required, when is it not. So if you think it is required, you give ICW4, otherwise you can skip that also. That means the only compulsory commands here are ICW1 and 2. But here's a question. Suppose you are 8259. I am the MUPI, I am initializing you. So I've given you ICW1, I've given you ICW2. Now you have a question in your mind. Should I start working or should I wait for ICW3 and 4? You don't have a question about ICW 1 and 2 because they are compulsory. That you know you are supposed to wait for. That you know I'm going to give. But you don't know whether I'm going to give ICW 3 and 4, or I may give 3 and not give 4, I may give 4 and not give 3. That is my choice. So how do you convey this to 8259 that whether you are going to give ICW 3 and 4? That you tell in ICW 1. I say for the last time, pay attention to everything I'm speaking. All of this will come back in a very big way. In ICW 1, you inform 8259 whether you intend to give ICW 3 and 4. You inform for each of them individually. Like I said, you may give 3 and not 4, or 4 and not 3, or both or none. That's everything is possible. But what you tell in ICW 1 is what you have to stick by. That means if you said in ICW 1 that you are going to give ICW 3, then you have to give ICW 3. Till the time you don't give it, it won't be accepted. It won't work. 8259 will not work. That means it will show you random behavior. Similarly, if you have said in ICW 1 that you are not going to give ICW 3, then even if you try to give ICW 3, it will not be accepted because you had said you're not going to give. So the fate of ICW 3 and 4 is decided in ICW 1 itself. Please tell me, did you understand? So just repeat this whole thing for me before we start. ICW 1 and 2 absolutely compulsory, ICW 3 given only if cascaded, and ICW 4 is given only if required. Once you do this, initialization is over. OCWs are our choice. They can be given whenever we want. They may not be given in any order, doesn't matter. Now, that was the basic idea. These are the commands. I'm going to be teaching you each command bit by bit. Tell me very frankly, honestly, what do you think? This is going to be simple or tough? It is so simple. 15 minutes it takes to understand this. 15 minutes, that's it. Once you understood it, you can teach it to people. It's that simple. How many marks does this come for? If this comes as a theory question, you get 10 marks. For doing what? For drawing these boxes. Yes, you have to remember the pattern. That nobody is taking away from you. You have to remember the pattern. Once you know the pattern, each bit is self-explanatory. If you understand it, you'll be able to write about all the bits by yourself. If you get a programming question on this, that is a jackpot. If I'm a student like you and I'm sitting for the exam and I see this as a programming question for 10 marks, this I promise you will be the first question I'll attempt in the paper, because I know I'll get 10 marks in 5 minutes, and plus it'll be short 10 out of 10. You can't go wrong in this. Once you understood it, it is ridiculously simple. So we'll be solving programming question as well. First we'll learn them in theory, then I'll be giving you a typical exam programming question. Initialize 8259 following specification, edge triggered, I see IR4 is masked and blah blah blah, whatever specification they give. That's a pretty long question, to be honest. So that's why I'm not saying the whole question. So anyway, they'll give you a full question and they'll give you specifications. Based on the specifications, you have to form the commands, and not only form them, then give them by writing instructions. Okay, that's the scope of this video. Okay, now, so our first command, ICW1. What do you know? ICW1 is optional or compulsory? Absolutely compulsory. 1 and 2 are absolutely compulsory. So let's focus on them properly, because whatever is the programming question in the exam, you know you will be giving these two commands for sure. There are many questions where you give only these two commands and that's it. Okay, so this is like bare necessity. First bit, IC4. What are you telling? Yes, you're telling whether ICW4 will be required or not. Remember, what did I say? In ICW1 itself, you specify whether you are going to give ICW 3 and 4. So that's what you're doing. This is about IC4. Now, by this bit, you're telling whether you're going to give ICW 4 or not. Now, every bit will do something when it is 1 and something else when it is 0. Instead of being a fool and trying to remember 1 means this and 0 means this, just know one sentence. 1 is true, 0 is false. For anything in this subject, 1 is true, 0 is false. So, whatever is the name of the bit, that is 1, 0 is the opposite of that. The bit is called IC4. Now, come on. 1 means ICW4 is required, 0 means it's not required. If you learn things like this, you will not have to mug up what happens on 1 and 0. All you'll need to do is remember these patterns. Yes, there's no way around it. You need to remember these patterns. But if you understand it, remembering the patterns becomes easy. Once you remember the pattern, the 1s and the 0s will follow automatically. Anyway, so that is IC4. SNGL. Single, yeah, very nice. Single or cascaded. 1 means single, 0 means cascaded. By this, you are indirectly also telling whether you are going to give ICW 3 or not. ICW 3 is given only for cascaded. So suppose I have kept both these bits 1. Suppose I have said it is single. That means I am not going to give ICW 3. You understand? It's given only for cascaded. So I am not going to give ICW 3. I've kept this bit 1, that means I am going to give ICW 4. So you're informing 8259 whether it should wait for ICW 3 and 4 or not. Are you clear? We'll come to this bit in a second. Just hold on, in a second we'll come there. LTIM. LTIM stands for Level Triggered Interrupt Mode. Say it again. Level Triggered Interrupt Mode. Now if you attended, or if the word attended keeps coming because I'm used to doing classroom lectures. If you have seen the video of 8259 architecture, the video just 2 videos before this, I have given the introduction where I've said programmer chooses whether we want interrupts to be edge triggered or level triggered. So this is where you make the choice. Level Triggered Interrupt Mode. So what do you understand? 1 means interrupts are level triggered, 0 means interrupts are edge triggered. So 1 means level triggered, 0 means edge triggered. Suppose they say in the exam, initialize 8259, blah, 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 edge triggered. That means keep this bit 0. If they say level triggered, obviously keep that bit 1. This bit is permanently 1. It is not don't care, it is permanently 1. These 2 bits are permanently 0. These 2 bits are permanently 0, 1, and they all have a collective reason, and that reason is so good when you understand it. Give me half an hour because that will come right at the end of this video after finishing everything. When you understand it, you are going to be proud of yourself. Like, wow, this is what you took engineering for, to understand real logic, not keep doing integration, not keep doing derivation, limits and things which are so abstract that you just lose interest in them unless you love maths. I used to. 100 out of 100, 12th standard, HSC board. What's the point? After a point, it just keeps getting more and more boring. But anyway, that's your personal choice. If you just love to multiply matrices all your life, good for you. But anyways, I don't. I like logic. And this is wow logic. Okay, but it's going to take time. Right now, just know this bit is permanently 1. These 2 are permanently 0. These 2 are permanently 0, 1. Now, we come to this bit called ADI. ADI stands for address interval. What do you remember? I told you, when we initialize 8259, what's the most important thing we have to tell 8259? The ISR addresses. Remember, ISR addresses of the interrupts. Now, how many interrupts are there in 8259? 8. Do you tell 8259 address of every interrupt? No. You only tell address of IR0. The remaining addresses are taken in a sequence. Do you remember that or not? Exactly. Now, sequence means there is an interval. That interval is also your choice, whether you want an interval of 4 or you want an interval of 8. If you've viewed the last video properly, the architecture video, I've explained all of this. So I say again, you give the ISR address of IR0. The remaining addresses are taken in an interval. The interval can be of 4 or 8, and that is also chosen by the programmer. 4 is sufficient because I told you, long time back in interrupts video, I've told you this. If a gap of 4 is fine, because see, you can never decide the size of an ISR. An ISR can be as small as possible, as big as possible. At those locations, ISRs are not stored. At those locations, a call to the actual ISR is stored. From where you return here, from here you return to the main program. So what you need to store is a call and a return. Call is a 3-byte instruction, return is a 1-byte instruction, so 4 bytes are enough. So a gap of 4 is fine, but if you want, you can also keep a gap of 8, which is typical of 8085. In 8085, between interrupts, there are gaps of 8, which also you know, 2-4, 2C, 3-4, 3C. That's not like because they are rhyming. There's a gap of 8. And that gap of 8 is so that apart from call and return, if there's anything that you want to do before calling the ISR, like push some register in the stack or whatever you want to do, you could do that extra operation. So that's why they've kept a gap of, given you an option of 8. So that applies over here also. You can keep a gap of 4 or a gap of 8, whatever you prefer. 1 is an interval of 4, 0 is an interval of 8. Again, everything by default is 0, so that it's compatible with 8085. 8085 had gaps of 8, so 0 is kept as 8 and 1 is kept as 4. Please tell me, do you understand this? Don't have funny ways of remembering 0 is a circle, so 8 and all. I've given you the logic, but anyway, remember it the way you like. So here you give the interval, whether your interval address interval is 4 or 8. So whatever they say in the exam, give it accordingly. Sometimes they do this. They say initialize 8259. I'm going to ask you questions, okay? Pay attention. Initialize 8259 as follows, blah triggered, blah, blah, blah. ISR address of IR0 is 4000. ISR address of IR2 is 4008. And etc. etc. baki ka information. Now, what you understood from this? ISR address of IR0 is 4000. ISR address of IR2 is 4008. So what is the address interval? 4. I'm sure you got that, right? ISR address of IR0 is 4000. ISR address of IR2 is 4008. Now between 0 and 2 comes 1. If 0 is at 4000 and 2 is at 4008, that means 1 is at 4004. That means the interval is of 4. Please tell me, do you understand? I don't come up with these questions, okay? I don't sit and think of all this. I have a life. But in all of these years of teaching, 18 years is a very long time. 36 semesters. I've seen so many question papers. I've seen variety of questions being asked. So this was asked in one paper and I remember it. Of course, the number may not be the same, but the trick was used was this. So I remember it, so I just told you. So sometimes the question is straightforward. Sometimes they twist it up and give you. So depending on which level of exam are you preparing for, whether you're preparing for GATE or whether you're preparing for a college unit test, depends on that. Anyway, so choose the interval appropriately as per the question. Now, so you don't give all ISR addresses. You only give the ISR address of IR0, correct? In that also there is an issue. Tell me, an ISR address is a 16-bit address, correct? ISRs are stored in the memory, so the address will be a 16-bit number. Now to give a 16-bit address, each command is 8 bits, so that means your address will be given using 2 commands, lower byte and higher byte, correct or no? So they will take up 2 full commands now. Instead of doing that, they used a very smooth idea over here. Suppose address of IR0 is 4260. Address of IR1 is 4264. I'm just saying any random addresses. So as you can see, the interval is of 4. Which address do you give? 4260, correct? Now, 4260 is 0100, 0010, 0110, 0000. This is 4260. Do you understand? This is the address that you have to give to 8259. Now you don't give this whole address in one piece because this whole address is a 16-bit number. All commands are 8-bit. So you understand it cannot be given in one piece. You give it in parts. How do you give it? This is A0, 1, 2, 3, 4, 5, 6, 7, 8, up to A15. So this is A0 to A15, correct? This whole bunch, the higher byte, A15 to A8, you give in ICW 2. A15 to A8. A15 to A8 of IR0 address. This is the address of IR0. In that A15 to A8 part you give over here. So 0100, 0010. 0100, 0010. That is 4 and 2, the higher byte of your address. This is given in ICW 2. Are you clear? A7, A6, A5 you give in ICW 1. Can you see? A7, A6, A5. A7 to A5 of IR0 address. Address of IR0, A7 to A5. So that means 011. 011 is what you give over here. Now, do you understand? ICW1 and ICW2 are the only 2 compulsory commands. 3 is given for cascaded, 4 is given if needed, OCWs are optional. So, suppose I am not giving anything else. My initialization by now should be over, correct? But if you realize you have only given 8 plus 3, 11 bits of the ISR address. How many bits are remaining? 5. Which 5? The higher 5 or the lower 5? The lower 5. The lower 5 bits of the ISR address are never given. They are supposed to be 0. The ISR address of IR0 has to be such a number whose lower 5 bits are 0. That is compulsory. Please tell me, did you understand this? We will take one more example. What's the problem? We will take one more example. If you have the will to understand, I think I have the ability to make you understand. But the first thing is the will. That has to come from you. I have the patience. I've seen every category of student or hopefully around. So some people understand things fast, some people understand some things fast, some things slow. Doesn't matter. If you have the patience, we'll do it again. Suppose I tell you initialize 8259 as follows. Address of IR0 is 7280. Address of IR2 is 7288. First of all, what is the interval? 8? No, 4, because this is IR2. Come on, don't fall for it every time. So IR1 will be 7284. That means the address interval is of 4. Tell me, do you understand that much? Now, which address do you want to give? 7280. That is the address you have to give. Now, 7280 is 0111. This is 7. 0010, that is 2. 1000 is 8, 0000 is 0. This part is given in ICW2. This part is given in ICW1. These 5 bits have to be such that they should be 0, because 8259 will assume them to be 0. Students say, sir, what if I store the ISR of IR0 at some address where this pattern is not 0? No, you cannot do that. When you're using 8259, these are the rules you're supposed to follow. ISR address of IR0. You are writing the ISR of IR0. ISR is a program. Write it at a memory location whose last 5 bits are 0, because you don't give those bits to 8259. There is no provision to give those bits. 8259 is designed in such a way that it will assume those 5 bits to be 0. So if you're starting from somewhere else, that is your problem. 8259 will not work properly in your system. So you have to take care of this, that the ISR address of IR0 has to be such a number whose last 5 bits are 0. Please tell me, did you understand this? Now that you understood this, you have understood what is ICW1 and ICW2. With this, your compulsory commands are over. Like I said, if it's a simple exam that you're preparing for, like your college exams, many a times the programming question doesn't even involve any other command. This itself is enough to write a programming answer. Whatever parameters they say, specify whatever they've specified in the question, based on that you write the bits and you give the commands and you're done. ICW3, when do you give it? Only for cascaded 8259s. Now what do you remember? 2 videos back, 2 lectures back, we had seen, last lecture in fact, last lecture we had seen cascaded 8259, the whole system. Now cascading means 9 8259s? No, nothing of that sort. 1 master, 1 slave is also cascaded, 1 master, 8 slaves is also cascaded. So there can be any number of slaves. If you remember the example that I had done on the board, there was 1 master and there were 3 slaves. Do you remember that? Slave on IR0, slave on IR1 and slave on IR7. Do you remember that or no? Now, tell me, based on that, try to remember that video, put a little stress on your head and answer. Whom do you initialize? Master or slaves? All. That means you do this whole procedure for all, not for 1 8259. Every 8259 has to undergo this whole procedure. In that, ICW3 are 2 separate commands given to the master and to the slave. This is the master, one for the master, one for the slave. This is the command for the master, this is the command for the slave. Now, what do you tell the master? Try to remember. With respect to cascading, what did we tell the master? Yes, on which lines there are slaves. You need to inform this, so that if an interrupt comes on that line, master will interrupt the MUP. When MUP will ask for the ISR address, master will keep quiet, allow the slave to pass the ISR address. Do you remember that or not? So that means we have to inform the master on which lines there are slaves. There are how many lines in the master? 8. That means there have to be 8 bits over here. S0 to S7. Obviously, what does S stand for? Slave. So whichever bit you keep as 1, that line has a slave. Whichever bit you keep as 0, that line does not have a slave. It has an ordinary device like a keyboard or a mouse, the ones that are used in the example when we had learned cascading. So in that example, there were slaves on IR0, IR1 and IR7. So similarly, we will keep IR0, IR1 and IR7 as 1. The others will be kept as 0. This number turns out to be 8 and 3. So your command value will be 83H. Please tell me, did you understand this? Like this, if there was, I'll give you another example. Suppose I say there are slaves connected on IR4 and IR5. That's it. Slaves on IR4 and IR5. 0, 0, 0, 0, 1, 1, 0, 0. So the number becomes 3 and 0. So your command value becomes 30H. Please tell me, did you understand? And so forth. So whatever they say as per the question, if they involve this part in the question, they will tell you which lines have a slave. So whichever lines has a slave, keep them as 1. Which doesn't have a slave, keep them as 0. Now that is the ICW3 you give to the master. There's another ICW3 that you give to the slave. What did you tell the master? On which lines there are slaves. What do you tell every slave? Come on, try to remember. Make me happy. Say it by yourself. What do you tell every slave? You tell every slave on which line it is connected to the master. That means you give every slave its identification number. Do you remember that? Is that number important? Super important. That is the number which the slave will compare with on the number that appears on the cache lines. Do you remember that? There are how many cache lines? 3, because the number can be anything from 0 to 7. 0, 0, 0 to 1, 1, 1. That is why ICW3 for the slave has only 3 bits which are useful. The remaining bits are garbage, keep, whatever, doesn't matter. 8 to 5 will not look at them. It knows the ID number will be there in the last 3 bits. So for the first slave, which was right at the top, which was connected on IR0, its slave ID will be 0, so you'll be giving 000. For the next slave, you'll be giving 001. For the last slave, you'll be giving 111. Students say, whom do you give this command? Every slave. Remember, you have to do this whole procedure for every 8259. Okay, so like I said, you got to do this whole initialization for every 8259, for the master also and for the slaves also. So this is common for all. This is the ICW3 given to the master. This is the ICW3 given to each and every slave. To the master, I will tell you have slaves connected on so and so, so and so, so and so line. To the slaves, I will tell what is each slave's identification number. For the slave 0, it will be 000, slave 1, it will be 001, last slave 7 will be 111. Are you clear? The remaining bits I don't care, so it doesn't matter. Did you understand why this is only 3 bits? Because the slave ID will be a 3-bit number. Also, if you're a deep thinker, what did you understand? Look at all this information and tell me, all this information is about what? Cascading. You're telling the master where are the slaves, you're telling the slave what is the ID number. So all this information is about cascading. That is why ICW3 is given only for cascaded 8259s. For a single 8259, all of this is meaningless information. Once you've told 8259 is a single, there is no scope of giving ICW3. Even if you give, it won't be accepted because there is no, all this information doesn't exist for single 8259. Tell me, did you understand? Now, we go to ICW4, the last of the initialization commands. ICW4, what do you know? Optional or compulsory? Optional. It is given only when required. So students say, sir, how will we know whether it's required or not? Will they tell in the question that, come on, they're not spoon feeding you. They will not tell in the question whether though I've seen one question. Once I've seen one question, ICW4 required, like how sweet. No, they will never tell whether ICW4 is required or not. They will tell the specification that they want. Look here, there are various bits over here. When you keep them 1, something happens. When you keep them 0, something else happens, correct? If you don't give ICW4, the 0 option in all these bits is the default option. Say it again, the 0 option of all these bits. The 0 option of all these bits is the default option. So, when do you give ICW4? Whenever you need the 1 option of any bit. Even for 1 bit, you need that 1 wala option, you need to give ICW4. But if you need that zeros option for every bit, you don't give. So, let me put it very simply. Are you a smart person if you are giving ICW4 with all zeros in it? No, you understood that, right? Because giving ICW4 with all zeros in it is as good as not giving ICW4 at all, because that would have anyways happened by default. You're just wasting your time giving ICW4 if you want to give all zeros. So when do you give ICW4? When you want to make at least 1 bit 1. Did you hear me? Don't give an ICW4 if everything that you're giving is 0, because that will anyways happen by default. If you want to keep even 1 bit 1, give ICW4 command. Tell me, are you clear? Now it will become more clear as we study the bits. The first bit over here, MUP mode. MUP M, that means MUP mode. So you're telling who is your MUP. Whether your MUP is 8085 or 8086. 1 means 8086, 0 means 8085. What did you immediately understand? If you don't give ICW4, 8259 will work like it's working with 8085. So for 8085 programmers, ICW4 is optional. If we need the other features, we'll give it. Otherwise, we don't give it, it's fine. For 8086 programmers, ICW4 is a compulsory command. Are you clear? So be careful which book you're learning 8259 from. If that book is written for 8086 programmers, the book will say ICW4 is compulsory. Because in 8086, if you don't give ICW4, 8259 will assume that it's working with 8085 and it will work very differently. So for an 8086 programmer, it's compulsory. But if you're learning this for 8085, then this command is not compulsory. It's only given if you need the other features. This bit will be 0 for you. Please tell me, are you clear? Now, AEOI. I have made a video on operation modes of 8259. That is exactly the same whether it's 8085 or 8086. So I've kept the video common for both channels. Now if you see that video, you will see there are various modes: FNM, SFNM, rotating priority, auto rotation, specific rotation, special mask mode, pole mode, normal UI mode, auto UI mode, non-specific UI and specific UI commands. Do you remember that whole video? So in that I've taught you there is something called normal UI mode where the programmer gives UI command, and there is something called auto UI mode where we don't give an UI command. UI happens automatically. On the third INTA bar, the bit will automatically become 0. So which is a better way of working, normal UI. Hence it is called normal UI. So that is also the default. 0 is normal UI mode, 1 is auto UI mode. I would love to explain those modes again, but I'll be just repeating the same information again and again. I have made a full video on it. Please check out that video to understand of UI modes. What is UI modes? Okay. Normal UI mode, you give the UI command. Auto UI mode, UI happens automatically. So it saves the programmer from giving the UI command, but it's a very bad mode because before the ISR begins itself, the in-service register bit is 0. So during the ISR, all interrupts of higher priority, lower priority, or even the same interrupt will interrupt itself. So it's not a preferred mode. That's why it's not kept as default. The default option is normal UI. If you want, or if the question says use auto UI mode, that is a hint. That means you have to give ICW4 because you want to make this bit 1. And to make this bit 1, you have to give this command. The 0 option is the default option. To make something 1, you have to give this command. Students say, okay, they've said use auto UI mode, so we will keep these bits 1. What about the remaining bits? Everything by default is 0. If they have not specified anything about the other options, keep the 0 option. That is the default option. M/S bar, straightforward, master or slave. 1 means master, 0 means slave. So depending on which 8259 you're giving this command to. If you're giving it to the master, keep this bit 1. If you're giving it to the slave, keep this bit 0. If 8259 is single, long time back in ICW1, you have told whether it's single or cascaded. If you have told it is single, then whatever you give over here is immaterial. It is a don't care bit, preferably keep a 0. Even if you keep a 1, doesn't matter. For single 8259, there is no master, there is no slave. In a cascaded system, this bit tells 8259 whether it will behave as a master or a slave. Please tell me, are you clear? BUF, buffered mode. You will not understand what I'm about to say. You will not. You will not understand. If you're an 8085 programmer, this bit does not apply to you. 8085 circuits are non-buffered. A buffer is a trans receiver 8286 which is applied on the data bus in 8086 systems, not in 8085 systems. 8085 systems are non-buffered. Now the simple way to understand it is, suppose I don't give ICW4 command. Look where my hand is moving. If I don't give ICW4 command, by default it works with 8085. By default it is non-buffered. Tell me, did you understand? Because 0 is the default option for everything. So being an 8085 programmer, for you this bit is always 0. Now sometimes examiners, just to irritate students, say buffered mode. If they say buffered mode, keep that bit 1. If they've said nothing, please keep that bit 0. 8085 circuits are not buffered. That option is there only in 8086. SFNM, special fully nested mode. You remember priority modes? The default priority mode is which one? FNM. So 0 is FNM, 1 is SFNM. SFNM is used only in cascaded 8259s. If you want the definition, in SFNM, master will recognize a new interrupt from a slave whose another interrupt is already being serviced. Do you remember that? I've done a whole video. I would love to explain everything again. That's my job. I love explaining. That's why I'm doing this. But what's the point of repeating the same thing again and again? Please check out that video on operating modes. Here I'm not teaching you operating modes. I've done a whole video for it already. So if they don't say anything, keep the default option. The default option is FNM, so this bit will be 0. If they said cascaded, it's your choice. Either use FNM or SFNM. Preferably use SFNM. That is created only for cascaded configurations. These 3 bits I don't care, will be permanently kept as 0. With this, we finish what? Initialization commands, the main commands. OCWs are optional. Most of the cases will never be required. Once again, let's just do initialization of the commands which are also useful in programming. Okay, so let's just go through this again. A7, A6, A5. The A7, A6, A5 bits of address of IR0. This bit is permanently 1. Edge triggered or level triggered. Address interval of 4 or 8. Single or cascaded. That means whether you're going to give ICW3 or not, and whether ICW4 is required or not. A15 to A8, the higher byte of the ISR address. So you're given 8 bits, you're given 3 bits, the lower 5 bits of the address are assumed to be 0. You're telling the master on which lines there are slaves. You're telling every slave what is its identification number. You're telling which MUP you're working with, which in your case will be 8085 if you're watching this video. This bit will always be 0. You're telling whether normal end of interrupt or auto end of interrupt. The end of interrupt, the default option is always normal end of interrupt. So this bit will be 0. If they say AEOI, auto end of interrupt, keep that bit 1. Master or slave, 1 master, 0 slave. If it is single 8259 immaterial, keep anything, doesn't matter, preferably 0. Buffered, non-buffered, 8085 circuits always non-buffered, keep that bit 0 unless they say in the question, design in such a way that it's a buffered mode. Like, it is a wrong question by itself, but what to do? You cannot argue with the examiner when you're writing an exam. So if they say buffer mode, keep that bit 1. FNM or SFNM, they will specify what they want. If they don't say anything, please keep that bit 0. The default priority mode is FNM. That finishes initialization, ICWs. OCWs are optional, out of which OCW2 and OCW3 are never used as a student. They are too advanced, much higher than at a student level. Yeah, if you're doing a PhD on 8259, or if you are using it in a professional way, then you need it. As a student, you'll never need it. I'll still give you a brief intro about it. OCW1, yeah, this is useful and this is super easy. You don't need me to speak a word. M0 to M7, 1 means masked, 0 means unmasked. Come on, say it by yourself. What are you doing? You are choosing which interrupt has to be masked. What? How people say this is difficult? What is difficult in this? Isn't it straightforward? You're telling which interrupt you want to mask. So question will say very clearly, mask IR2 and IR3 as an example. If they say mask IR2 and IR3, keep these two bits as 1, keep these bits as 0. Your number becomes 0. This is C, 0, C, H is your command. Give me my marks. Come on, it is so simple. This is what gives you marks in the exam. Anyway, did you understand this? So that's OCW1. Okay, now answer. I masked 2 and 3. After masking 2 and 3, after some time, I feel like unmasking them. Can I unmask? Yes. Can I mask again? Yes. Can I mask something else again? Yes. Can I unmask again? Yes. What do you understand? OCWs can be repeated. Remember I told you, ICWs are never repeated. OCWs can be repeated because what the information that they give is such information that you want to give again and again. So you can anytime give, okay, what if I don't want to do masking? Don't do. So this command is optional. You may not just do masking at all. OCW2 and OCW3, like I said, it's used in very, very advanced applications. Again, I would love to take half an hour and explain this and this, but there's something called overload of information. I don't want to do that. I don't want to corrupt your mind with information which I know you'll never use from any exam point of view. If you're a student learning this, yeah, if you're a professor, that's a separate thing altogether. If you're a student, you really don't need to know this, all this at all. But still, I'll tell you what it is. Grasp as much as you can. L2, L1, L0, line number, IR0 to IR7. So suppose you keep over here 0, 0, 0, it's IR0. 1, 1, 1, it's IR7. R, SL, EY. These are 3 bits. 3 bits will give you 8 options. Say again, how many options? 8 options. With those 8 options, you select different modes. Okay? You select different modes, different operating styles. The idea is the mode that you select over here will not apply to the whole 8259. It will apply to the line you have selected over here. Did you instantly understand how advanced this command is? This is 4 levels higher than what you're learning. Okay, to be very frank with you, this is not student stuff. All of these commands, whatever you do, you are affecting the whole chip of 8259. You're deciding how 8259 will work. But in this command, you can decide a different behavior for every interrupt line. You can have IR0 working in a different way, IR1 working in a different way, and so on. Per line, you can give this command and specify exactly how you want every line to behave. Now, there are 8 options over here. Specific UI, non-specific UI, rotate on specific UI, rotate on non-specific UI, auto rotation set, auto rotation clear, set priority command, and no operation. You don't need to know this. I'm not showing off by telling this. I'm just making my point clear that yes, it's not like I'm not telling you because I don't know. I know, but there are things which I'm not a news reader. There's a big difference between learning from me and learning from a book. A book will also give you information which a book doesn't know you, doesn't know what are you learning it for. So will in all probabilities give you overload of information. That's what happens in those prescribed textbooks. That's why we close them and run away from them. So I don't want to give you information which I know you'll never use. If you still want one example, what happens over here? There's an option over here called set priority command. When you give that option, whatever line number you choose over here, that will become the lowest priority. Remember I told you, you can alter priority mechanism. So one by one, you can keep giving this command and decide the whole priority structure the way you want. There is something called as rotating priorities. Remember rotating priorities? So that also you decide from here. Whether you want auto rotation, whether you want rotate on specific UI, whether you want rotate on non-specific UI. It will take me half an hour to explain to you the meaning of each one of them. And as I said, I'll be using your energy at a place where you will never actually be useful to you in the exam. This is what you really need. You don't need this. If you still want to know this, what's happening, I'll give you a short audio of it. It's really not required, not as a student, not from a student point of view. Anyway, so there are 8 options that you choose over here and this is the line number. So you choose what option you want and you program the line as per your desired option. I gave you one simple example, set priority command and give the line number. Whatever line number you tell over here will automatically become the lowest priority. Are you clear? Not the highest, the lowest. OCW3, again used for very advanced application, but it is too simple. So I can, by the time I convince you why I'm not telling you, in that much time I'll be able to tell you this also. It's that easy. And this bit is don't care. 2 bits, 4 options, 0 and 0 and 0, 1, nothing will happen. So they are dummy options. 1 0 and 1 1. Exit SMM and enter SMM. What is SMM? Special mask mode. Do you remember special mask mode? If you get an interrupt of IR3, you are in the ISR of IR3. During that, IR 0, 1, 2 will be serviced. IR 4, 5, 6, 7 will be serviced. The only one not to be serviced will be IR3. So this is a mode used where you don't want priority. Anybody can interrupt anybody except for the same interrupt. Since you are specially masking the current interrupt, it's called special mask mode. I have explained to you what is special mask mode. This is how you enter and exit special mask mode. Are you clear? Again, as a student, you'll never do it. These two bits permanently 0, 1, P, poll command. Remember what is polling? Opposite of interrupting. Polling means asking. Instead of you giving me an interrupt, I will ask you, do you have a doubt? So instead of 8259 interrupting the MUP will poll 8259 and ask whether there are any interrupts. So how do you poll? By giving a poll command. Is there a command by the name poll command? No. OCW3 with the P bit as 1 acts as a poll command. Are you clear? RR and RIS. 0, 0 and 0, 1, nothing will happen. 1, 0 and 1, 1. Read IRR, read INSR. I repeat, read IRR, read INSR. Do you remember in the architecture of 8259? Do you remember in the architecture there was an IRR and there was an INSR? I'm sure you remember that. That I'm not asking. I'm sure you remember that. If you have a very good memory, right above these two registers there were two buses going up. Do you remember that? That's my question. If you remember that, I'm very happy. That means you have either seen that video many times or at least you practice the diagram. So there were buses going up. What does that mean? Programmer can read these two registers. If you read IRR, you'll know which interrupts are requesting. If you read INSR, you'll know which interrupts are in service. So you can read. You'll come to know who is occurred. You'll come to know who is being serviced. So as a programmer, you can read these two registers. If you give 1 0, you're reading IRR. If you give 1 1, you're reading INSR. That's OCW. Let's just do a recap of the OCWs. So simple. Tells you which interrupt you want to mask. Gives an option and tells the line on which that option should be applied. Enter and exit SMM, read IRR or INSR and poll command. That's it. That's OCWs. So that was the ICWs and OCWs. If you get a theory answer on this, you'll get 10 out of 10 because you're remembering the patterns. What happens on 1 and 0 is very obvious. If you know the pattern, then 1 0 will form automatically. Just remembering the pattern will give you 10 marks. So many students run away from this. There are only 10% students in the whole university who are able to write this, out of which most of them have by hearted it. If you understood this, I hope you found it interesting also and very simple also. Now, don't stop here. Don't stop here. No. Knowing this in a theory question is nice. It's good. Sometimes they don't ask a theory question. Sometimes they ask a program. They say initialize 8259 as follows. So take down your book and listen to this question. I'll also try to display it on the screen. Or anyways, I'll just say it very slowly. Initialize 8259 as follows. Edge triggered, single, edge triggered, single, auto EOI mode, non-buffered, mask IR3 and IR7, ISR address of IR0 is 6980, address interval of 4. That's the specification. I repeat the question. This is how the question comes. It's a 10-mark question. It's 10 marks for the taking. You see this question, jump on it. In 2 minutes, it will give you 10 marks. 2 minutes. Okay? And full 10 out of 10. Edge triggered, single, auto EOI mode, non-buffered, mask 3 and 7. ISR address of IR0 is 6980. Interval is of 4. Are you clear? That's your question. Now let's solve it. What do you have to do in this question? Based on the specifications they have given, you have to form the commands and then give the commands. That giving part will come later. First, you have to form the commands. Now, which commands are you going to form? Are you going to form all the 8 commands? No. If you do that, and if I am the examiner, I won't even check the solution. We'll give you straight 0. The first thing you need to know is which commands are necessary, what is not necessary, why are you wasting everyone's time by forming and giving those commands. Now, do you give ICW1? Yes. ICW2? Yes, because they are compulsory, they have to be given in every case. Do you give ICW3? No. Why? Because it is given for cascaded. The question says single. Do you give ICW4? Yes. Why? Because of that one single specification. Which one? Auto EOI. Because they said auto EOI, that means you have to give ICW4. Masking, yes, they have asked you to mask, so you have to give OCW1. So these 4 commands you will be giving: ICW1, ICW2, ICW4, OCW1. OCW2 and 3 never given as a student. Anyway, there's nothing in the question that needs you to give it. To form a question also for giving it will be crazy. Program IR0 in such a way, program IR2 in such a way. Come on, never happens. Anyway, at least in 18 years I've never seen that. So we won't be requiring these 4 commands. So I'm just erasing this so that we have space to do the further part. Though I will keep this here because I still need it. Now, pay attention here, Let's form the commands. Come on, don't be scared. First, ICW1. Do we need ICW4? Yes, because it's auto EOI, so we will be giving ICW4. They've said it is single. Single means this bit will be 1. They've said address interval is of 4. 4 means this bit will be 1. They've said what triggered? Edge triggered. Edge triggered means this bit will be 0. This bit is a permanent 1. ISR address of IR0 is 6980. Now 6980 is 0110. This is 6, 1001, that is 9, 1000 is 8, 0000 is 0. This will be given in ICW2. So ICW2 will be 0110, 1001, 69, 69H. This will be given in ICW1. So it will be 100. These 5 bits are always assumed to be 0. Are you clear? So this number becomes 9 and 7. 97H is your ICW1 command value. 69H is ICW2 command value. Please tell me, are you so far clear? Now, ICW4. These 3 bits are always 0. Don't care. Now, your MUP is 8085. You will not believe. Once a student asked me, so which MUP should, like, come on, man, come on, don't ask. Come on, you know which microprocessor you're learning. So this is for 8085. You think they will tell you in the question, remember you're learning 8085? Like, really? Anyway, so this bit is 0. Auto EOI. Auto EOI is specified. That's the reason why we are giving this command. So this bit is 1. Master slave doesn't matter because they have said it is single. Once you've told it to find it single, it won't even look at this bit. Give whatever you want to give. I'm keeping it as 0. Buffered or non-buffered. Remember, 8085 circuits are non-buffered. Non-buffered is the default option. Since they have not interfered with it, you should also not. Same goes with FNM, SFNM. SFNM is never used in single. SFNM is created for cascaded 8259. So this bit will be 0 because it is single. So the number is 0. This number is 2. So your total number is 02H. Are you clear? 02H is your command value. Lastly, they have said mask IR 3 and 7. Mask IR 3 and 7. So 3 and 7 have to be masked. The others are unmasked, so the others will be 0. So what does the number become? 8 and 8, 88H. Your command value is 88H. So these are your 4 command values: 97, 69, 02, 88. Are you so far clear? Now, listen to this. If you stop here in the exam, it was a 10-mark question, you stop here, you will get 5 marks. Are you happy with 5 marks? Remember, if you know the command patterns, you would have got these 5 marks in 2 minutes, okay, or less than that. I'm explaining while I'm teaching, so I'm taking so much time. It will be much lesser than that. But if you want full 10 out of 10, you have to also give these commands. Now, how do you give these commands? Who is giving these commands to whom in the circuit? MUP is giving these commands to 8259, correct? For the MUP, 8259 is an IO device. Which are the instructions used to transfer data to IO devices? In and out. In means you get some data from an IO device. Out means you send data. You remember in and out instructions, stack, IO and machine control group, in that last group. So you will be using out instruction because you want to send commands. So in and out instructions work only on A register. So this is how your program will be. MVI A, 97H. Put the command value as data in A register. What is command? It's a data. It's a number that you'll be sending. So put that 97H in A register and do an out at the address of 8259. That address, either in the specifications of the question they would have written, assume 8259 has so and so address, or many a times they don't write it, you choose your own address, whatever address you want to choose. 8259 is an IO device. Please do not confuse that address with this address. Come on, you're not a kid. Come on. This is the address of ISR. ISR addresses are 16-bit addresses. 8259 is an IO device. Remember, IO devices have 8-bit addresses. You remember that, right? Don't get confused in such petty things after learning such big things. You know 8259 is 8259, 8255, 8254 are like keyboard, mouse, printer, monitor. They're all IO devices. IO devices have an 8-bit address. So either they will give an address or you can choose any address you want to. Okay, so we will keep any address over here. I will fill that address later. First, let's write our program. Then again, MVI A, 69H out dash. MVI A, 02H out dash. MVI A, 88H out dash. What are these? ICW1, ICW2, ICW4, OCW1. This is how you will be giving your commands. Are you clear? Please do not change this order. You change this order, the commands will not be accepted. If you remember right in the beginning of the video, I had told you the commands have to be given in a particular order. So this is the only way you can give it. Okay, do not change it. Now, the addresses. Either they will give you an address or you assume an address. Now, the most beautiful part of this whole lecture will happen right now. I want your best concentration. I know it's been long. You've been sitting and paying attention to that. I've been talking to a camera for this long, okay, and I'm maintaining my concentration. I'm damn serious, okay. I want you to be very serious for the next 5 minutes, okay. So either they will give you an address or you choose an address, okay. Now, since 8259 is an IO device, the address will be an 8-bit address, so you can choose any address you want to. Let's say the address is 80, fine. So clearly write, okay, in very clear words, assume 8259 is at address 80H, 80, okay. So since 8259 is at 80, you will be giving ICW1 obviously at 80H, that's the address of 8259. You will be giving ICW2 at, are you giving ICW2 to some other chip or to the same chip? Same chip, right? Same 8259, so what's the big deal? You will be giving that also at the address 81H, not 80, 81H. I told you the most beautiful part of the lecture is going to come now. You will give ICW4. Now come on, properly. ICW1 we give at 80, ICW2 we give at 81. There is no ICW3. You will be giving ICW4 at the address 81. Yes, 81. You will give OCW1. Now properly. OCW1. You will give at the address 81. If there was an OCW2 to be given, you would give that at the address 80. If there was an OCW3 to be given, you would be giving it at the address 80. The students say, what is going on? How is the address behaving like this? There is only one thing on the whole board which is in the same color. Purposely I was doing that. I don't know how well the camera is capturing colors. In the classroom, students instantly spot what I'm trying to hint at. There's only one thing on the board at this color. Look here. What is that? With every command, I have written a value of A0. Can you see that? That value decides the address at which the command will be given. Be very serious. You know what are you starting? You're starting designing of 8259. Yes, designing will be covered in the next video, but it's plantation. The seed is going to be planted right now, and this is going to go very long way in your understanding of designing. I want your best concentration here, okay? I'm damn serious. 80 and 81 are addresses. When the address changes, some bit of the address will change. If you look at 80, 1000, 0000, that's a binary form. 81, 1000, 0001. So the only thing that changed between the two addresses was the lowest bit of the address. What is the lowest bit of the address called? A0. The commands for which A0 is 0. These are the three commands, ICW1, OCW2, OCW3. They have A0 as 0. They will be given at the address 80. The commands for which A0 is 1 will be given at the address 81. I will make you understand everything. I promise you. Give me your concentration. ICW1, ICW2, ICW3, ICW4. OCW1, OCW2, OCW3. A0. A0 behaves like this. A0 is 0 for ICW1, 1 for the remaining ICWs, 1 for OCW1, and 0 for the remaining OCWs. Now what happens as the effect of this? If I tell you 8259 is at 80H, if I tell you 8259's address is 80, the commands will be given at 80, 81, 81, 81, 81, 80, 80. If I tell you 8259 is at 40H, come on, 40, 41, 41, 41, 41, 40, 40. 8259 is at 62H, 62, 63, 63, 63, 63, 62, 62. First of all, are you clear? Please, for God's sake, don't mix this with this A7, A6, A5. Please, please, I say for the nth time, this was A0 to A8 to A7, A6, A5 of ISR address. Of whose address? ISR address. ISRs are stored in memory. This is address of 8259. 8259 is an IO device. Please do not get confused. Up to this point, people understand and they give up. You don't want to be a quitter. You have reached here. You've climbed the whole mountain. You just have to put that flag there. Come on, you're at the last step. Don't give up right now. Those were ISR addresses. That is a separate thing. Now I'm talking about address of 8259. 8259 is one chip. Okay? It is one chip, but it consumes two addresses. What are the two addresses? 80, 81, or could be 40, 41, could be 42, 43, could be 84, 85. Basically, 8259 consumes two addresses. Those two addresses are being formed due to A0. Students say, why? Why is this happening? Why this torture? No, this is not torture. This is mind-blowing intelligence. This is made so intelligently. We are just understanding this. Imagine how crazy people are. People, what is their IQ level who come up with all this? This is like, wow, man. Now, I'll make you understand it. All this is happening because of A0. Now, A0 is a part of the address bus. When A0 changes, address changes. That's how you're getting 80, 81. If there was no A0, students say, अगर ये नहीं होता तो कितना easy होता यार? Sub command. If A0 was not there, then all of these commands would be given at the same address 80, correct? So what's the problem? The problem is, I am the MUPI, you are 8259. I am going to give you commands. How many? 7. ICW 1, 2, 3, 4, OCW 1, 2, 3. Suppose I am giving all commands, correct? If I give you all the 7 commands at the same address, not at the same time, that should be stupid. How can I give 7 commands at the same time? You're not learning magic. Data bus is 8 bits. Only one command will go at a time. You cannot write MBI, A, comma, this, now out all of them. Come on, let's not joke. I'm going to give you the commands one by one, no doubt. But if I give you all the 7 commands at the same address, 80, 80, 80, 80, 80, 80, how will you ever come to know which command am I giving? How will you know whether it's OCW2 or OCW1 or ICW1 or what? Because they're all coming at the same address. These multiple addresses are created so that commands can be given at different addresses so that they can be recognized by 8259. Tell me, so far are you clear? I just started. Did you understand what I said? Students say, no sir. No. If 8259 had to recognize 7 commands, then they should have been given at 7 different addresses. You are right. But then if it was that simple, we would be learning all this in school. This is engineering stuff, okay? This is a degree that makes you a professional. So the logic also is going to be of that level. 8259 is so intelligently designed that it can identify 7 commands using only 2 addresses, okay? It doesn't need you to give the commands at 7 different addresses. It says, just give me 2 addresses and I can identify all the 7 commands. Who does it? 8259. Do you want to know how it does it? I won't tell you. You will tell me. If 8259 can do it, I'm sure you can do it. I'm sure you believe you're smarter than an 8259, right? If 8259 can do it, how can you, a human being, not be able to understand this? This is not cutting edge technology. This is something which was made in 1977. Obviously you can understand it. Okay? Come on. Also the year that I was born. Anyway, so I am the MUPI, you are 8259. I am going to give you 7 commands. I am not going to do this again and again. One attempt, you understand it, great, otherwise I will explain. But that will be a shame. Don't make me explain it. Understand it by yourself. 1000 batches I have taught, I have never really explained this. People understand it. I am sure you will also be able to understand. You are 8259, I am the MUPI. I am going to give you 7 commands. You have to identify which command is what. The only hint you have is they are coming at 2 different addresses, 80 and 81. Let's start. The first command I give you at the address 80, the very first command I give you at the address 80, what do you think? Which command it is? ICW1. Excellent. How are you so confident? At the address 80, I could have given you OCW2 also and OCW3 also. Yes, but they cannot be given before an ICW. ICWs are given first. Moreover, ICWs are compulsory. Moreover, ICW1 absolutely compulsory. That means the first thing that comes to you at the address 80 has to be ICW1. Are you damn sure about it? Good. So have you identified it? Yes. Will you mistake it for some other command? No. Once you identified ICW1, forget about it. Get it out of your picture, because ICWs cannot be repeated. Remember 45 minutes back I told you all of this will come back together in the most beautiful logic you've learned from me so far. So pay attention. Once you identified ICW1, forget about it. Now ICW1 cannot be repeated, so it won't come back now. So now you're left with 6 commands and you still have 2 addresses, 80 and 81, to identify them. Now the first command that comes to you at the address 81, which one is it? 81. Yes, yes, I can see you smile. Has to be ICW2. How? There are 4 candidates at 81. I agree. And OCW can never come before an ICW. ICW 3 and 4 cannot come before ICW2. They have to be given in this order, and ICW2 is compulsory. You can't even skip it. So there is no way you would have skipped ICW2 and gone and given me ICW3. So if I give you a command at 81, you know for sure it is ICW2. Are you clear? Now, once you identified ICW2, forget about it. Throw it out of the window. It cannot come again. Are you clear? Now you're left with 5 commands and still 2 addresses, 80 and 81, to know which command is coming at which address. I give you a command at 81. Could be ICW3, could be ICW4, could be OCW1. Cannot be ICW2. ICW2 is out of the picture. It cannot come again. That is for sure. But it could be ICW3 or ICW4 or OCW1. How will you know which one it is? Because in ICW1, I have informed you whether I am going to give you ICW3 and 4 or not. Using that as a reference, you will come to know whether it is ICW3 or it is ICW4. Say for example, I have told you I am giving you both ICW3 and 4. So the first command at 81 has to be ICW3. Next command at 81 has to be ICW4. Suppose I have told you I am giving you none. That means the next command at 81 directly is OCW1. Suppose I am told you I am giving you ICW4 and not ICW3. That means ICW3 is out of the picture. 81 pe the next command is ICW4. Are you understanding what I am saying? Because I have told you in ICW1 whether I am going to give you ICW3 and 4. Even if I am giving you both, and I've told you I'm going to give you both, that means they will come in this order only. That means the first command at 81 will be ICW3, the next command at 81 will be ICW4. Tell me, will you be able to identify these 2 commands? Are you clear? Also, once you identified these, ICWs are over. They cannot be repeated. They are out of contention. Now you're left with only 3 commands and you still have 2 addresses to identify them, 80 and 81. I give you a command at OCWs are more tricky. There are no rules on OCWs. They can be repeated. They can come in any order. They may not even be given. Okay? Pay attention. If you're already smiling, you know the answer. And I'm damn proud of you. I like students who understand before I open my mouth. Good. OCW1. I give you a command at 81. Which one is it? Has to be OCW1 because the other candidates of 81 are over. They cannot come again. Their time is gone. So I give you OCW1. Will you know it's OCW1? Yes. After 10 minutes, I give you OCW1 again. Yes. Again. Yes. Again. Yes. Why am I giving again and again? Masking. I can keep changing the masking pattern. Every time I give you OCW1, you will know it is OCW1 because the other 3 commands which could have come at the address 81 cannot come again. Are you clear? So that means from now onwards, the address 81 is booked. 81 is for OCW1. Anything coming at 81 blindly will be treated as OCW1. Are we clear on this? Yes? Good. Now comes the question of OCW2 and OCW3. Both are optional, both can be repeated, and both can be given in any order. Are you understanding? How will you know? Suppose I give you 5 OCW2s, 5 OCW3s, then again 5 OCW2s. That means I have given you 15 commands, all at the same address 80. In between I have given you a few commands at 81. You know 81, every command of 81 is OCW1. You're not worried about that. But I have given you 15 commands all at the address 80. Still, will you come to know which is OCW2 and which is OCW3? Yes, because in the command values of OCW2 and OCW3, remember in the command patterns of OCW2 and OCW3, in pink color I had shown you something, 1, 2, 3, 4 and 5. The fourth and the fifth bit was 0, 0 in OCW2, 1, 2, 3, 4 and 5. The fourth and the fifth bit was 0, 1. So in the pattern, in the command, please understand, this is the address, this is the command, this is the address, this is the command. A command coming at the address 81 is simply OCW1. A command coming at the address 80, if the address is 80, 8259, before understanding whether it's OCW2 or OCW3, we'll look at the command. We'll look at the fourth and the fifth bit, starting from this side, from the MSB, the fourth and the fifth bit. If the fourth and the fifth bit are 0, 0, it's treated as OCW2, 0, 1, it's treated as OCW3. That's why they have fixed patterns. I told you the reason will come back and will hit you very hard. See how wonderful all this is. This is not like one night somebody thought of it, okay, let's do this. This is made out of tremendous logic, and that's how all these chips are made. Every chip you learn, if you understand them properly, you get mind blown by it. Anyway, so any command that comes at the address 80, 8259 looks at the fourth and the fifth bit. If the fourth and the fifth bit are 0, 0, it's OCW2. If they are 0, 1, it's OCW3. Are you clear? So I give you 10 OCW2s, 10 OCW3s, 10 OCW2s, some OCW1s, then OCW2s. It will still know which command is which one. That's how 8259 identifies 7 commands using only 2 addresses. Now students say, all of this done, just one doubt. If you still have a doubt, I really like you. Because you like me now. Good. What is remaining? Students say, sir, yes, we are in the operating stage. We can't give any ICW again, but you had told us you can always repeat the whole initialization again. So I can repeat this whole set again. Yes. Now if I want to repeat this whole set, I will start by ICW1. That means randomly during operation times, I may just decide, oh, I want to do the whole initialization all over again. I will start giving ICW1. Now if I suddenly out of the blue give an ICW1, ICW1 will also be given at the address 80. At the address 80, there was already confusion. How did we solve the confusion? By the fourth and the fifth bit. If the fourth, fifth bit are 0, 0, it's OCW2. If they are 0, 1, it's OCW3. 1, 2, 3, 4, 5, 6, 7, 8. If the fourth bit itself is 1, I told you these bits are there for a reason. If the fourth bit itself is 1, that means it is ICW1. And once ICW1 is identified, the remaining sequence will start all over again. With the same logic, it will identify all the commands. Please tell me, did you understand this? 1% of students who learn 8259, 1% understand this logic so deeply. If you understood this, great. You will not be explaining this anywhere in the exam. But this is the foundation to understand designing. A person who understands this understands that basic DNA on which the whole designing of 8259 and thereafter designing of various chips will happen. You got a grip on something which is going to help you understand big topics very easily. This goes very deep in terms of understanding. Tell me, did you understand how 8259 identifies all the 7 commands? Now, like I said, you're not going to explain this to anybody. This is not the part that gives you marks. What gives you marks is drawing the commands, getting the command values right, giving the program correctly at the correct addresses. But if you haven't understood that, you'll have to mug up the addresses. If you understood it, you know which command is given at which address. ICW1 is given at 80, ICW2, 3, 4 are given at 81, OCW1 is given at 81, OCW2 and 3 are given at 80. Please tell me, are you clear? So, what is the role of A0? The role of A0 is to identify the commands. To simplify it, this is 8259. This is its data bus through which 1, 2, 3, 4, 5, 6, 7 commands are going to enter. This is A0 line. Now when you give a command to 8259, you will be giving that command at address 80 or at address 81. Now depending on whether your address is 80 or 81, A0 might be 0 or it may be 1. If A0 is 0, the address is 80. If A0 is 1, the address is 81. So whenever A0 is 0, the command over here can be either ICW1, OCW2 or OCW3. For that, it will look at the fourth and the fifth bit of the command and will understand and interpret the command in that way. If A0 is 1, then the command can be ICW2, 3, 4 or OCW1, which it will identify by the sequence in which they have occurred. Please tell me, are you clear? So that's the role of A0, to identify the commands within 8259. With that, we finish ICWs and OCWs. I hope you understood it. I've put in a lot of effort to make you understand this. I hope you got it. Wish you all the best. Do well.